I hope that everybody is having a wonderful morning so far. This is Atmospheric Alex here with yet another update on the potential tropical system that'll be entering the Gulf of Mexico next week. We will be doing this update in great detail, looking at satellite imagery, the National Hurricane Center, future model data, and so much more than that. And I hope you all stick around to the very end, as this is going to be a bit of a lengthy video. I do apologize for that. So we're currently taking a look at our satellite imagery here of this tropical disturbance. And I just want to note that we do have a lot of deep convection that is starting to occur right over where this area of circulation is. And, possibly over the next day or two, this could lead to a bit more quicker organization. And, we really hope that doesn't happen, because once it organizes, y'all know what's going to happen. It's going to move north into the Gulf, where at that point, it'll have all the freedom to intensify. So we're rooting for this system. We're pulling for this system to delay its development, to kind of be a bit of a slowpoke in some terms. Well, we're going to take a look at the National Hurricane Center's weekly outlook here, and you can see where our disturbance currently is right now, marked in the red. And hey, would you believe it or not, because we actually have a 70% chance of tropical cyclone formation. Those are pretty high probabilities if you were to ask me. And if you're looking down in the text, down at the bottom of your screen here, you see that a tropical depression is likely to form while the system moves slowly northward across the northwestern Caribbean Sea and Gulf of Mexico through the end of the week. So yes, tropical development is becoming more likely by the day, and some would even argue by the hour, which we're about to see here in just a little bit. But first, I'm going to bring back a bit of a visual guide that I used a little while back called the Tropical Weather Triangle. What on earth is it? Well, it's basically a triangle, with three sides. Each side has a certain parameter that will lead to the development of a tropical system, right? Well, side number one is your sea surface temperatures, your current, water temperatures, how hot everything is right now. And let me just tell you, we have sea surface temperatures where this thing is forming upwards of 31 degrees Celsius. Wow, that is getting into your upper 80s right there. And I will say, thankfully, it is cooling off a little bit, but really won't make a difference until it gets under 28 degrees Celsius, otherwise known as your low 80s. Very favorable conditions ahead. Well, as we look further off to the north here, you can see sea surface temperatures, 29 degrees Celsius, all the way up until potential landfall. Great. That's fantastic. So, you're probably going to have a strengthening system roughly up to landfall. Now, this isn't the only parameter you need to look at. Before we look at our other parameters, let's look at our ocean heat content values, which, not too good, is it? Well, we have values upwards even over 200. Probably some values approaching 220, 230 still. And I want to note as well, you have a bit of an eddy here. It's really more of just a consolidated current at this point. Upwards of 150 to even 180 OHC. So you're probably thinking, well, Alex, that's great and all, but what is OHC? It's basically how far down these waters go, these warm waters go. So the more OHC you have, the stronger your system could become. And that is what we're talking about here. You only need values of 100 or greater to support rapid intensification. well, we have 150 to 180 here. So I really don't need to say much else other than that. This is going to be a system we really need to watch over the next week, just in case it pulls any surprises like history suggests. Okay, now that we're done looking at side 1 of our triangle, let's take a look at side number 2, and that will be a wind shear. So basically, for a tropical system, you need a fairly generous amount of wind shear, very low amounts. If you have too much wind shear, your center is going to get a little bit tilted, which is going to cause less circulation, your system to wind down, to get shredded apart, like a cheese grater. I said this in the other episode here. That's what this is like. Well, we're going to take a look at our GEFS model. We'll look at these more in depth later. You can see your beautiful upper level anticyclone here that begins to develop. It's not complete, but it doesn't really matter, right? When you have a low wind shear down here as well. But you can see very well pronounced here, and this is basically the breeding grounds for a tropical system. Or I should say your breathing grounds. And that is what we're concerned about, because under these conditions, these systems can rapidly intensify very quickly. Look at this envelope here, of wind shear staying well away from the system. Very favorable conditions. We're talking about, potentially upwards of only 10 knots of wind shear in here. Yeah, this could get very serious over the next few days to come, depending on where this envelope of wind shear goes. Will it go directly into the system and shred it apart to oblivion, or will it stay outside of it and let it grow more and more and more and become a serious issue later on? What does your GEFS say? Well, that your system is going to remain in very favorable conditions. Quite favorable up until landfall, that is, where your wind shear envelope does creep southward into your center of circulation and start to disrupt it a little bit more. So depending on if your circulation is here or here will really depend on just how rapidly or even explosively the system can intensify. But now let's look at side 3 and your last side of your tropical weather triangle. This is your moisture content in the atmosphere, and you can see, yeah, there's an awful lot of moisture down here, isn't there? Again, breathing grounds. This system will be able to breathe in and breathe out very efficiently. And that will make it feel nice at home to rapidly intensify. Possibly. It's not always a guarantee, but it is definitely a lot more likely in this situation. Just take a look at this. Yeesh, a lot of moisture streaming northward. You do start to notice a tiny bit of dry air trying to kind of seep into your western side, but that is not nearly enough, especially if you have a tightly packed inner core. At landfall, though, you definitely see a lot more dry air trying to make its way in. There is still enough moisture, though, unfortunately, to sustain a hurricane landfall here. And as this thing moves on shore, dry air kind of just chokes it out. Just like that. Well, at least that's what most models are thinking. There's some that don't, and we'll get to those later. So, your tropical weather triangle. I'm going to draw this out for you to hopefully help you understand. We have a gigantic triangle here, in the shape of this. At the top here, we have your water temperatures. I'm going to put it in WT, water temperatures up there. You need very warm water temperatures to sustain a tropical system. Down here, we're going to look at your wind shear, down here, your WS icon there. And then over here, we're going to look at your moisture content, your MC over here, which that would stand for. It has another, it could stand for something else as well, but in the terms of weather, moisture content is MC in this case. So let's go ahead and, check some stuff off. So our water temperatures. Yep, you have a very hot Caribbean and Gulf of Mexico right now to support this system. I'd give that a check mark indeed. Your wind shear. Well, you could see some intrusions towards the end, so we're going to give that a little bit of a dash mark there. I still do believe that it won't be much of an issue, but right before landfall, it could start to erode at our western edge and weaken the system a tiny bit. And your moisture content, yeah, I'd say you have a decent amount of moisture content to sustain the system. At landfall, it will become a little bit shaky, but with a strong central inner core, your system will be just fine. I could tell you that much. And thus, all these ingredients here will indeed support a tropical system to develop like so. Now we're going to take a look at your GFS model, but we're going to do a little something different this time. I'm basically going to become my own TV meteorologist here, and I'm going to be standing up and I'm going to be reporting the weather as if I'm on the air. Quite exciting, right? Well, let's get straight to it. So we have our system right now that is just down there, emerging out of the Caribbean, moving up to the north here, and as you can see, getting pretty strong as a tropical storm into a hurricane entering the Gulf, and bam, landfall right about there in the Florida Panhandle, moving up north, looking like potentially some significant inland impacts could occur from a system like this, moving this quickly inland. As we play through one more time, you could see our system right down there that is starting to develop, and look at that, gaining more vorticity as it gets more energy from Central America, becoming a bit of a hurricane there in the Gulf and rapidly intensifying, bringing lots of rain, wind. Look at that landfall there for a panhandle going just to the west of the southern Appalachian Mountains. Again, these inland impacts, what I'm thinking right now, could include very heavy rainfall, all right? Rather strong winds, especially up in the mountains. Some of your fall foliage might unfortunately be getting stripped off of the trees, so just keep that in mind if you're going up there for any reason. Well, that was fun, right? Let's do it again, this time with the European model here. So, as we look through time, it starts as some shower thunderstorm activity down there in the Caribbean, if I can point, and you can see some rotation getting going. I think this will occur a lot sooner, though, as we already have convection down there. And take a look at that there. Starting to really get going as it shoots the gap between the Yucatan Peninsula there and Cuba. And we are seeing a lot more vorticity in that spot. History speaks for itself right there. And you can see it does become somewhat of a strong tropical storm, maybe even a hurricane there in the Gulf. And look at that, a landfall, Florida Panhandle again. So we have some consistency. Look at those inland impacts. Wow. Yeah, going right into the mountains there as well. So certainly a fast-moving system, and that is going to cause a lot of heavy rainfall, even some damaging winds well inland. So we're going to have to keep an eye out for this system very, very closely. All right, we're going to do it with one more model, the European AI model here. You can see our convection starting to bubble up down there in the Western Caribbean. Gets organized a lot faster this time, which I agree with a lot more. Tropical storm in the Gulf, even a hurricane there, and look at that. Bam, right there, landfall. We're talking about the Florida Panhandle near the Big Bend region. So we do certainly have a bit of model consistency with this system thus far. So we'll just have to continue to monitor these model trends, because they could change overnight tonight. We just don't know. Our steering patterns, we're going to look at that in just a little bit as well. Well, I hope you all enjoyed that lovely stand-up presentation of the weather, classic TV style there. And there's a lot of stuff I need to work out, of course, and that'll happen later down the road. Don't worry, I have very big plans on the way for that. And if you didn't enjoy that section, well, let me know as well in the comment section down below. Feel free to criticize me. I really don't mind, as long as it helps me out in the long run. I have no issues there. Well, let's take a look at our steering patterns here. This is from the GFS model. You can see our system here getting well organized here in your blues. These are your areas of lower pressure here and lower temperatures in your upper levels. And we're starting to see something unfold here. Well, we have a large trough out here, large low pressure system, digging down a bunch of cooler air here. And we have a weak high pressure system starting up over here along the eastern seaboard. So what is this going to do? Well, your high pressure flows like this, and because it's weaker, it might dig into it a little more. And your trough of low pressure, well, does this. Where in the world is your system going to go? Well, something like, if there's moving parts here, this, right? Well, let's go ahead and take a look at that. So, seeing our system here, and right at about landfall here, we see this trough of low pressure here actually gets connected to the system. What this is going to do is it's going to make this move a lot faster off to the northwest. And it'll even try and bend it back inwards again, as a lot of our ensemble models are suggesting. Because remember, with your high pressure flow down here, you're gonna see a tendency to do a more of a northwest jog at the last second here. And you could see that quite nicely here. It makes landfall, again, Florida panhandle here potentially. Could be further west, could be further east, so I'll have to time that out. You could see after it makes landfall, it begins to curve like this because of your ridge up here. And also because this thing does what's known as a Fujiwara effect. It sounds like a made-up term. It's not. It's, I believe, made by a researcher named Fujiwara. I believe it sounds like a name anyways. You could see your trough of low pressure, it's now a cutoff flow, because your high pressure up here has essentially severed it from the polar influence. So what this is going to do is your flow around the low pressure goes like this and boomerangs it off to your north at considerably fast-paced speeds here. Upwards of 30 to 40 miles an hour. This thing's going to be screaming off to the north here, which will provide inland impacts. Like I said, with our stand-up presentation. And it gets absorbed in your low pressure system here, it eats it up, and well, this just kind of becomes a bit of a weak storm system that will probably, be pushing more into the southeast, getting even more rain into those areas that, at that point, really don't need anything else. Your European model? Well, I'd say it's quite similar. There's a few caveats, though. This doesn't develop nearly as fast, and, we'll have to see if that scenario pans out. You begin to notice your high pressure here, not as far south, but your low pressure, your trough, look at that, digging much further south, and this is going to come down here, sweep it off to the northwest. High pressure is going to build, and it's going to sweep it off over here, fling it to the northwest, over in that direction. So general northeast to northwest curvature there with your tropical system, with your future hurricane here. You can see, again, picks it up, flings it around. Your high pressure here actually begins to get a little stronger and is a lot further up to your north. So it'll allow for a much sharper turn here off to the northwest. There you go. Just like that. It's a little stronger, so then it does try to curve a little further north, and you're left with actually a much stronger storm system here. Maybe even, I wouldn't be shocked if you see maybe some severe weather on the front side of this. We'll have to wait and see what models say all the way out next Saturday. That is ridiculous. Yeah, it's about a week out at this point, and things could change. This high pressure could be gone for all we know. Probably not, though. We've seen consistency for these models. Okay, so what does your ensemble model say in terms of your individual plots here, your individual low pressures on your models? Well, you can see this model in particular already shows development here of a potential tropical system. I don't want to say cyclone because then you're going to think we're in Australia. We're not. This is a potential tropical system that is starting to develop down here. Western Caribbean. Yeah, you get the idea. All the models showed that. Blah, blah, blah. Now show us the Gulf and the landfall impacts. Yes, I'm going to do that. Well, it intensifies a bit faster than some of the other models here. You see a couple of plots here. You get down in the 60s here, even in the 50s, mid 50s. Might even see a 40s in there. Yeah, so definitely, It's a little far out to say this, but history has proven time and time again there is a very slight chance that the high ceiling here is a major hurricane landfall. But it's not a forecast, so just keep that in mind when I say that. But very, very tight agreement here, considerably here, with even, look at that, a member there down to 936 millibars. Wow. Cat 4 potential? I don't really think so, but you never know with your Gulf of Mexico waters now. Very tight agreement here. And on a Florida Panhandle or a Florida Peninsula landfall. We'll figure that out over the next few days. And there you go. Look at that. Direct landfall. You even got a 44 going north of Tampa. Please don't pay attention to that right now. If the National Hurricane Center says major hurricane for Tampa, then pay attention. But I'm not saying that yet. That would cause a lot of storm surge, so hopefully that doesn't happen. And this really kills the system. Don't really agree with this. You still see few members there down into the 70s and 80s, providing substantial inland impacts if that does come to fruition. European, same song and dance. We don't have to go through it that fast here. You could see not as strong, but very tight consensus here on a Florida Peninsula landfall, more than a Panhandle landfall. So, again, further east, I could definitely favor some of these scenarios here. I just drew an arrow into Tampa. Didn't mean to do that, but it could just go a little bit further east in general. We'll wait and see. One thing to take away, a lot of inland impacts. Wow. A lot of 80s, a lot of 90s, even a couple 70s. So very bona fide, potentially a strong tropical storm moving into, the southeast Appalachia region there. Even East Tennessee could see some impacts. Your mountain wave high winds. If your systems do track, a little further off to the west, that could potentially favor a lifting and a displacement of your mountain winds here to strongly come off the mountains. Could even see some damaging winds in the foothills. So if you're in East Tennessee, I know a lot of you who watch my channel are, you need to pay attention to the forecast, all right? And local news sources as well, and I'll of course be around for any updates that are needed. So now, really quickly, we're going to go through your Icon EPS ensemble forecast here. I didn't know they can combine two models together, but they are doing it here. But you can see your system flash warning here becoming well organized. We see, look at that, couple of major hurricane signatures there. If we're going off the high end, which wouldn't shock me, again, same song and dance, Florida Peninsula, Florida Panhandle, moves onshore. Some of your later lazy members here going into New Orleans. That's not going to happen. No need to worry. All right, well, that about does it with today's video. I hope you all did enjoy. Yeah, it was quite a doozy, wasn't it? And then I really hope you enjoyed the stand-up forecasting there. And if you did enjoy, I'd highly recommend you smash that like button, maybe even subscribe to my corner of the weather community. Share this with friends and family, and turn notifications on so you know when I upload next. Very important information. Well, with that being said, I'll see you all in the next video, hopefully in a couple of days. We'll wait and see with the crazy scheduling. That being said, this is Atmospheric Alex here, signing out. I hope you all have a wonderful afternoon.